sample problem, a window 2.4 meter long and 1.5 meter high, recessed 300 mm from the outer surface of a wall facing 10 degrees west of south, using the following data. Determine the sunlit area and the solar heat gain. We have the design month, that is March 31, and we have also the direction, which is 10 degrees west of south. The condition locations, we have 40 degrees north of latitude, and we have the solar time, which is 2 o'clock p.m. For the glass specifications, we have the thickness, which is 6 mm. The type, we have heat absorbing. Shading, we have medium Venetian blind with interior shading. Given a certain window glass, we have your design month, which is equal to March 21. For the location, we have 40 degrees north latitude. And we have the solar time, which is 2 o'clock p.m. and for the glass specification, so we have your thickness, and we have the glass specification properties. Bringing down the figure, we have here the sunlit area, and we have your top view ng projection ng sun. Okay. Then solution from table for the 13, page 78, Stoker, March 21st at 2 o'clock p.m. and we have 40 degrees north latitude. Bringing the table for the 13 of the Stoker, that is in page 78. Then we have the month, which is March 21, no? So that will be April, that will be March 21. So take note, we have here 40 degrees latitude, then you have 32 degrees north latitude. I will bring down other tables, bro. I will find other tables. Usually we have different latitude compared to this one, and yung location natin sa Philippines, so ibang north latitude. Later on, I will bring down table para doon. Now we have March, no? So we have the properties for your March. So we have 40 degrees north latitude, that will be March and September, and we have your solar time, so that is given at this is the peak, which is not actually the peak, but per look it is hinahanap yung we have a given time. But in our design consideration, so you will notice here we have the solar time, that is 7654, that is started at 12 1 2 3 4 5 6 7, so that is in PM. So it will be different then yan if you have sa umaga, you have the solar time, and we have also the angle. Okay. So considering sa problem we have March, no? So that will be 2 o'clock. So we have your given value here. Then we have your angle. We have the angle for the solar altitude, that will be 42, and for the solar azimuth angle, so we have also value of 42. So we can draw a line. So yun. Then let's draw a line here again. Okay. We have the value of 42. For the given value, we have your angle 42, and we have also 42 degrees and another 42 degrees here. Now solving for the azimuth angle, so we have the following equation, no? So that will be 42 degrees minus the 10 degrees, which is equal to 32 degrees. Now solving for the depth of the shaded area, we have your equation D times the tangent of your angle divided by your cosine, okay, that angle for the azimuth. So substituting the value, we have 0.3 times the tangent of 42 degrees divided by the cosine of 32 degrees. Then we have the value of 0.32 meters. Okay. Now solving for the width of the shaded area, we have your x is equal to d times the tangent of the angle. Then we have 0.3 times the tangent of 32 degrees. Then we have the value of 0.19 meters. Now solving for the sunlit area, so we have your equation kanina, so that will be h, that will be minus y, then we have your length minus your x. So substituting the value, we have 1.5 minus 0.32, then multiply by 2.4 minus 0.19, then we have the value of 2.61 square meter. Then solving for the solar heat gain, bringing down the equation for the solar heat gain, we have the solar heat gain factor for a single sheet of clear glass multiplied by the shading coefficient. So then we have that one, and we have the cooling load factor, and you have your area. Now March, that would be March southwest and 40 degrees north latitude. So from table for the Stoker at page 75, so that will be March, so 40 degrees latitude, no? And we have the southwest, you have the value of your solar heat gain. Solar heat gain factor is 730. That would be watts per square meter. Now the heat absorbing glass, so we have from table 4-11 of Stoker, page 76. We have the heat absorbing, and it is Venetian blinds, medium light. So we have the shading coefficient value, which is equal to 0.57. Now 2 o'clock p.m. southwest is looking to the table for the Stoker, page 77. So we have here your southwest, no? Then this is 6, 7, 8, 9, 10, 11, 12. Okay, we started here 1 o'clock, 1, and this is your 2 o'clock, since we are in the 2 o'clock time. Then intersection nila, we have 0.75. So you have your cooling factor, which is 0.75. So the solar heat gain, substituting yung value natin na nakuha natin sa table, we have now the value of 730. That will be watts per square meter, multiplied by the shading coefficient, that will be 0.57, multiplied by the cooling factor, that will be 0.75, then multiply with your sunlit area, which is 2.61 square meter. So cancel out your units. Then we have your load ng glass, solar load with glass, so that will be equal to 814.52 watts. Okay, so hindi naman siya complicated, madali lang naman siya. It's just a matter of looking at the tables, no? Being familiar with the tables. For the other area, I will bring down other tables. Siguro I will upload that one para you'll be aware of how to compute. Kasi usually now looking at what I have here is a Google Earth, no? Okay. So looking at the Google Earth, you will see for the grids that we have here, yung nandito tayo banda sa between north, which is 15 degrees, 5 degrees. So 5 degree, 5, 15, yun natin here, 25, 35, and another 45 here. So yung data na binibigay doon sa aklat, which is we have 32 degrees north latitude and 43 degrees north latitude. Okay, so mapapansin nyo dyan, we are far beyond. So kung 42 is somewhere here, 42, and 32 here, dito yung latitude. Now we are classified doon sa 15 degrees and 5 degrees. And I will upload na lang ito yung I will look to the ASHRAE. I think meron sila ng 15 between 15 and 5 degrees latitude that we have here. So